In this video, I'm going to explain about another sequence, also called as a data structure in Python, that is called tuple. So in my previous video, I explained about list items. How do we arrange the elements in the form of a list? How to access individual items? How to access subset of items? How to access all items? How to add a new item? How to delete an item? How to print them in reverse order, how to arrange them in ascending order or descending order or increasing order if they are numeric. So first I will explain some theory part related to tuple. Just I'm opening the document that is available in my system. Yes. This is about tuple definition. Tuple is a sequential data type. Slicing can be used, and all these things you can see here. First I will go to the first one. Yes, this one. A tuple is a sequence. I'm going to highlight the things. It is a arranging the data. Anything is called a sequence. Data structure definition is also called as arranging the data in a particular order. That order is another synonym is called sequence. A tuple is a sequence of Python, and in tuple the objects are separated by commas. Yes, even in list also the objects are separated by commas. Only thing is we are using here parenthesis. It looks like similar to a list in terms of indexing, in terms of nested objects and repetition. But coming to lists are mutable, but here tuples are immutable. Tuple is immutable unlike list. That means we cannot modifiable tuple elements. We cannot change. That we have to remember. The difference between the list and tuple is in case of list, items can be modifiable. Means we can add new element, we can delete a new element, we can insert any new element at our required position. All these operations are possible on a list. Why? Because lists are mutable. Coming to the tuple, tuples are not mutable, means immutable, means it cannot editable or changeable. And how do we create tuples and all those things I will explain later, and I'll explain the program. And accessing elements of a tuple can be done same as like how we are accessing individual items in list, how we are accessing subset of items using slicing technique on list, and how we can access all items in a list. The same way here also we can access tuple individual items or individual elements, subset of elements, and all elements of a tuple can be accessed like this. Using positive indexing we can access. Using negative indexing also we can access. Positive index, negative index, and all. Slicing is also applicable. Like if this is the input data set, as I told you that tuple elements are enclosed in parentheses. If you are applying 1 colon 3 means one index value, two index value is printed. What is the one index value? B. What is the two index value? C. The third index is not considered. As I told you that if you remember for list, I specified start index value, I specified stop index value, and I specified step index value. So three arguments it is expecting. Here only two arguments are available here. 1 colon 3 means one is considered as start index, 3 is considered as stop index. If start index is missing, how it is assumes. If stop index is missing, how it assumes. If a step index is missing, how it assumes. So all these things we already discussed in my previous video under lists. Now I will explain all these concepts through a sample program. I will open ideally, open a new file. So I'm creating a tuple T1. Tuple elements are enclosed in parentheses. So how the Python interpreter identify these elements are tuple elements, these elements are list elements based on the symbols that are used to enclose the elements. Like this. And I am printing all the items, all elements of elements in tuple T1. Before printing the result, just I am printing a message. End user point of view, we need to provide this message. I am printing the tuple. Before run, save the application in the respective directories. This is a demo program on tuples. We'll run this application. See, elements in tuple T1 or whatever the elements I define at the time of initializing, declaring, I initialize with 10, 20, 30, 40, 50, 60, 70. All elements are printed as it is as part of the output. Now, this is called accessing all elements. Accessing all elements in tuple T1. If I want to access individual elements, then I can use indexing technique, positive indexing technique. Same as a negative indexing also I can use. Accessing individual elements, individual element. If it is individual elements, then we can go for slicing. First, I will explain about accessing individual elements in tuple T1. I'm going to access the third element in tuple T1. So what is the element that is located at third index? Third element means that is located at second index. This is first element, this is second element, this is third element. This is located 0, this is located 1, this is located 2. So here I need to specify 2, T1 of 2. If something is enclosed in double quotes means that is printed as it is. If something is not enclosed in double quotes means the value that is holded by this one is printed at the time of displaying the output, and string contents and non-string contents are separated by commas. See, I am accessing individual element in tuple T1. So tuple T1, I given index value as 2. So that is the reason it prints 30. Suppose if I given one more element, just I am copying the previous statement and I am pasting. So for example, if I want this 60, that is located index 5. So for example, if I want this 40, that is located index 3. So this is index 5 means that is representing sixth element. Index 3 means that is representing fourth element. So once we made any changes, immediately have to save it and run the application. So third element is 30. Yes, this is first element, this is second element, this is third element. And sixth element, 1, 2, 3, 4, 5, 6. 6 means 60. And the fourth element means 40. First element is 10, second element is 20, third element is 30, and fourth element is 40. And one more thing. And this is about accessing individual elements. Similarly, accessing individual elements using native indexing. I want to get the last element directly. So how can I do it? I will show you. Accessing individual elements in tuple T1 using negative indexing. The above one is using positive indexing. Now I am copying these statements. Suppose if I want to print last first element, last to first element, that is located at -1 indexing. Suppose if I want to print last second element, last second element, that is located at -2. Suppose if I want to print last fourth element, then I need to print -4. Save this and rerun the program again. See, last first element is 70. Yes, this is last first. And last second element is 60. And last third is 50, but we are not printing. But last fourth we are printing, that is 40. So last first element is 70, last second element is 60, last fourth element is 40. So like this, we can also access same as like list. In list also, we done the same set of operations while accessing individual elements as well as using positive indexing as well as negative indexing. Now the next one is accessing subset of items. Accessing subset of items. So I'm providing this message before displaying the result. Accessing subset of elements. Subset of elements in tuple table. So using slicing it is possible. So print. So for first subset 1, name of the tuple is T1. In square brackets, you can specify 0 colon. So 0 colon means, again I will open the Word document and I will show you the syntax of slicing. So for example, here in our case it is the name of the list is this one, and here it is expecting start index, stop index, and step index. So three things are expected. Just I'm increasing the font size. You can observe. So start index, stop index, and step index. So three arguments are expected. If you specified only start index, does not specify stop and step, then the default stop value is assumed, default step value is assumed. What is the default stop value? The default stop value is up to the last element in your tuple. What is the default step value? By default, each element is jumped by one step. Step is one step. If you want to jump 2 steps, you need to specify step value as 2. If you want to jump 3 steps, you need to specify step value as 3. That is here. Just I'm changing the color on this one. Okay. So start value, stop value, and step value. That means start index, stop index, and step index. Here I specified only start value. I did not specify stop value. Stop means it will read up to the last element in the tuple. Step value means by default, after reading the first element, it reads the second element. After reading the second element, it reads the third because it jumps only one step. So based on that, it will apply. Save this one and run this program. If you see here, the first subset what we generated starts from 0 up to the last. So 0 is called 10. Up to the last means 70. Indirectly, we are printing the entire tuple using this slicing. So for example, the same program, if I made changes, this is another subset, the next subset, in place of 0, if I keep 2, what happened? 0, 1, 2. So from 30, it reads all the elements in the tuple. So 30, 40, 50, 60, 70 are going to be printed. I will check the program. You can see 30, 40, 50, 60, 70 print. Why? Because I clearly specified the beginning index, the start index value as 2 colon. I did not specify last index, means stop index. So up to the last element in the tuple, it will consider. And after 30, it prints, it jumps only one step, that is 40. After 40, it jumps only one step, that is 50. For example, here, this one here, and then this one. In case of subset, I am going to generate one more subset, that is 3, 0 colon. Here I did not specify stop index, I specified jump values 2. If I specified jump values 2 means after 10, it prints 30. After 30, it prints 50. After 50, it prints 70. Like that, it jumps. That is the meaning of jumping 2 steps. After 10, 30 prints. After 30, 50 prints. After 50, 70 prints. That is subset 3. So we are expecting that result in place of subset 3. So after 10, it skips 20 and 30 prints. After 30, it skips 40 and 50 prints. After 50, it prints 60. Sorry, it skips 60 and prints 70. So that is the use of jump indexing, step indexing. Suppose if I don't want to read all the elements. I want to read up to particular indexing. Suppose 60 is located at index 5. So if I given 5, but for fifth index value not considered. So beginning from 0, 0, 1, 2, 3, 4 means total 5 elements are considered. Now all 5 elements after printing the first index, 0 index, it prints the second index. After printing the second index, it prints the fourth index. Means only 3 elements are going to be printed as part of this subset 3. 3 elements. After printing 10, beginning index, it skips the first element 30. Previously, it reads up to 70. Why? Because we did not specify the stop. Where to stop, we did not specify. The default stop index value is up to the last element in your tuple. So in this way, we can use this one, stop indexing. Step index, so just now I shown you how can we jump 2 steps. Start value. If you did not specify start index, what will happen? I will show you. One more subset I'm going to generate. This time I'm not specifying start index value. I will specify only stop index value as 6. I did not specify the step index value. Step index default one is 1 step. So 6 means it starts its journey from when the start index is not specified. It assumes from the beginning of the tuple up to the last index minus 1 means 6 minus 1, that is called 5. So fifth index is this one, 60. If you see here the output, I will change. I will save this one and yeah, once we made any changes, I forget to change the subset number. Actually, this subset number is 4. In the description, just correct it. It's a 4. It is a fourth subset in our program. You can say this one. So 10, 20, 30, 40, 50, 60. So here I did not specify the beginning index. I specified only end index as 6. 6 means the sixth index element is not part of the output. Sixth minus 1, that is called fifth index. So up to fifth index it's printed, and after printing the first element it jumps only one step. So 10, 20, 30, 40, 50, 60. So like this we are applying different types of slicing operations on the original elements of a tuple. See, tuple elements are enclosed in parentheses and accessing all items like this, and accessing individual elements by using positive indexing as well as negative indexing. If you want to access subset of elements, then we can go for indexing like this. Suppose if I want to print the reverse order of the tuple, so that can be done using reverse order. Reverse order. I did not specify start index value. I did not specify the stop index. Only I specified jump value as -1. You can see the reverse order prints reverse order. Original list contains 10, 20, 30, 40, 50, 60, 70. So the reverse order is like 70, 60, 50, 40, 30, 20, 10. So in this way, we can access individual elements using positive indexing and negative indexing, accessing a subset of items using slicing, and accessing all items by specifying the name of the tuple.